Here's a design challenge that sounds impossible. You want to create an object that is completely immutable after construction, no mutations allowed once it's built, but you still need a way to populate it during construction. How do you allow initialization without allowing ongoing modification? Traditional approaches all have problems. You could use a constructor with parameters, but that only works for simple objects. You could use a builder, but the builder exists outside the object and anyone with a reference to the builder can still modify things. You could make the methods public and just trust callers, but that's not enforcement, it's a suggestion. The revealing constructor pattern solves this with a counterintuitive technique. The constructor accepts a function as an argument. Inside that function, and only inside it, special privileged capabilities are available. Once the constructor completes, those capabilities are gone forever. Think of it like a safe deposit box at a bank. When you rent the box, the bank lets you open it and put things inside. After that, the box is locked. The bank no longer has a key that can open your box alone, only both keys together work. The window for modification was brief, deliberate, and supervised. The revealing part of the name refers to what the constructor reveals. It exposes internal modifier functions to the executor callback, but only for the duration of that call. After construction, those functions simply no longer exist anywhere that external code can reach them. This pattern is described by the book as particularly characteristic of JavaScript and the Node.js community. It appears in some of the most widely used APIs in the language. But before we see those real examples, let's look at the book's implementation, an immutable buffer. The book demonstrates the revealing constructor pattern with an immutable buffer, a buffer-like object where the data can only be set at construction time, after which it's permanently read-only. Here's how it works. The immutable buffer constructor accepts two arguments, a size for the buffer, and an executor function, the same callback pattern you know from promises. Inside the constructor, a real buffer is created with the given size. Two special operations are defined: set, which writes a value at an index, and fill, which fills the buffer with a value. These two operations are passed to the executor function as arguments. The executor can do whatever it needs: call set repeatedly to populate the buffer, call fill to initialize it, compute values, copy data. It has complete write access. When the executor returns, those references to set and fill simply go out of scope. They're not stored anywhere on the immutable buffer object. They're not on the prototype. They don't exist anywhere reachable from outside. The buffer's internal data array is accessible for reads through the get method and other read operations, but there is no path to mutation. The calling code looks like this: const buff equals new immutable buffer 16, set equals set 0, 255, set 1, 128. After this constructor call, the buffer with values 255 and 128 at positions 0 and 1 is permanently fixed. Notice the elegance: the immutability is enforced by the structure of the code, not by trust, not by documentation, not by convention. There is literally no API surface through which you could accidentally modify the buffer after construction. This precision of capability exposes exactly what's needed, exactly when it's needed, and no longer is the pattern's defining characteristic. The revealing constructor pattern is most famous for one specific implementation that every JavaScript developer uses every day: the promise constructor. Think about how you create a new promise. You write new promise, resolve, reject, equals. Inside that arrow function, you call resolve to fulfill the promise or reject to reject it. And here's the crucial question: once the promise is created, can you call resolve or reject from outside that arrow function? No. You can't. Those functions were passed to your executor, and that's the only place they ever exist. This is not an accident. It is the revealing constructor pattern, used deliberately. The promise reveals resolve and reject, the two operations that can change the promise's state only to the executor function. From the moment the constructor returns, those operations are completely inaccessible. The promise is sealed. This design choice has profound consequences. A promise, once an appending state, can only be resolved or rejected by whoever created it and holds those closure references from the executor. Code that receives a promise as a parameter cannot resolve or reject it, they only get the read side, the then/catch interface. The write side is hidden away in a closure. The same pattern appears in the browser's ReadableStream API. The ReadableStream constructor takes an executor that receives a controller object, a handle for enqueuing data, closing the stream, and signaling errors. Once construction is done, that controller exists only inside the executor's closure. External code can read from the stream but cannot push data into it. Both of these are exactly the immutable buffer example, scaled to production APIs used by millions of developers. The revealing constructor is not an academic pattern, it's the pattern behind one of JavaScript's most important abstractions.